From the beautiful North Studios of Way Happy, this is Mr. Meyer and 3-5 linear equation is three variables. Now, that sounds pretty intimidating, but what it is we're just going to graph a point in three variables. Now, just a quick reminder, how do you graph in two variables? When I give you an x and a y, let's say 2, -3, right? That's your x and that's your y. And so you knew that you went out to the x-axis, you went 2, and then the y-axis you'd go -3, and then you'd follow that chart, and wherever those two intersect, that was your point. Well, awesome. And you've done very well at that. Now, a lot of life is three-dimensional. In fact, everything in our life is three-dimensional. A lot of TVs now are three-dimensional. How the heck are they going to program this if everything we do is in two dimensions? That's not going to work well. So we have three dimensions that we need to talk about: X, a Y, and a Z. And if you want to know how it's graphed, you can see right next to there's the X-axis, which you might notice is different. The Y and the Z kind of look like they did before, but their variables have changed. And that's just to let you know that I'm in three dimensions. Now, again, y going positive is this way, y going negative is this way. And, z positive is going up and z negative is going down. X positive is this way. It's supposed to look like it's coming towards you, where X negative looks like it's supposed to be going away from you. It's supposed to be going into my computer screen, but I can't show that on two-dimensional paper. How am I going to graph three dimensions? So we have to kind of get magic here. And so let's pick some numbers like 1, 4, 3. Let's make one of them negative. You guys care? Let's do the 4 negative. So if I was going to graph that, that means on the x-axis I have to go to +1, which means like diagonally you're going to come out 1. I usually will graph these two first. So the y-axis is -4, 1, 2, 3, 4. The z-axis is +3, 1, 2, 3. So that would be like right here, right? But that's not my point, because what it has to do is it has to come traveling on this. You want to be parallel to the x-axis. You want to come out 1 unit, which would be like right about here. And that is where the point would be. Now that looks ridiculous, right? And you're kind of right. It is. That's the location of the point. If you want, some people like to draw a little box to show them where it is. It would look something like this. There is the crazy looking box that it would be at that location. But what I do is I usually graph the YZ first, and then I make a parallel to the x-axis, and then I move forward or backwards depending on which way I have to go. And that right there is plotting in three dimensions. It's a little hokey, but here, we'll give it a try. So how would you want to do this? So here, I'm going to graph all of them on the same graph paper so I don't have to get too carried away. So here's my y and here's my z, which is super confusing because you've been told all the time that that's x and y. X is coming towards you and negative x is going away from you. So there's your graph paper. Now, if I want to graph this first one, again, I'm going to kind of cheat. I'm going to go -2, 1. So -2, 1 is right here. But that's not my final point. I'm going to put it now 3 units on this diagonal. Now, look, I'm kind of making this up. I'm like 1, 2, 3-ish. It's right there. That's where point A is. So you see how I kind of just hokey 3 tick marks and made it happen. What about the second one? I'll do it in red, say. So -1 and then -3. Again, I'm doing my y and my z first. And then I got to be parallel to the x-axis. And I need to go 2 units out. So 1, 2-ish right there. And you have yourself a beautiful graph. And then last but not least, this guy here, he's at 0, 2. Oh, let's do him in blue. So 0, 2 is right there. And then kind of almost that same axis, I'm going to go back 1, and there it is. And that would be C. I forgot to label B. And there you have your points. A, B, and C. All right. I think, I'm going to ask you a question. I'll be right back after this. Excellent work. All right. Now let's talk about this one. I want you guys to graph a linear equation. Now that seems a lot harder, right? You know that in two dimensions, when you plot 2 points, it makes a line. Well, in 3 dimensions, guess what? You're going to plot 3 points, and if you remember from geometry, 3 points make what we call a plane. Now, I think this one's kind of nasty, but we'll see. So there's my x-axis. There's my y-axis, and there's my z-axis. Now, how on earth do you plot? Well, you use the cover-up method because that's the only way that works really well, right? So say I want to find what we call the x-intercept. Well, if I'm going to find the x-intercept or where it crosses the x-axis, then I'm going to make y a 0 and I'm going to make z a 0. So if you make y and z both zeros, you will see that I get 2x minus 0 plus 0 equals negative 6. I don't know what that's doing. Go away. And if I divide that, I get x equals negative 3. And so that is what we call the x-intercept. Now, the correct way to write that is negative 3, comma 0, comma 0. In other words, x is negative 3, y is 0, z is 0. So where am I going to plot that point? I'm going to go back 1, 2, 3 on the x-axis, put a big old dot, and there is your x-intercept. Now, guess what? Same exact system for the y-intercept. So for the y-intercept, that means that x is going to be 0 and z is going to be 0. So if you plug that in, you get 0 minus 3y plus 0 equals negative 6, or y is 2. Again, the correct way to write that would be 0, 2, 0. So guess what? On the y-axis, we're going to go to 2. And I'm going to put a big old dot at 2. And then last but not least, the z-intercept is when I make x and y zeros. And so what do we got? 0 minus 0 plus z equals negative 6. So that means z is negative 6, or the point 0, 0, negative 6 is on the graph. So z-axis 1, 2, 3, 4, 5, 6. And I will put a big green dot there. And those 3 points make up a plane. So the plane would be this point to this point to this point, and those 3 points make up this entire plane that represents that equation. So that equation is graphed by those 3 points making what looks like a triangle but is actually a plane, and therefore you have your solutions by finding the x-intercept, y-intercept, z-intercept, and you can graph. All right, let's do a word problem. Track relay, you score if you run out in track and have a relay team. They get 5 points for first place, they get 3 points for second, and 1 point for third. So Lynn's team scored a total of 30 points in the relays. Could you tell me how many times they got first, second, or third? Or could you at least make an equation in part 1? Well, sure. 5 times the number of times they finished in first, plus 3 times the number of times they finished in second, and 1 times the number of times they finished in third would equal 30 points. I just made you an equation. And part B. If Lynn's team was second 6 times and third 2 times, how many times did they get first? Well, you just told me that this is a 6, and you just told me that this is a 2. And so what do I have? 5x plus 3 times 6 plus 1 times 2 equals 30. I'm pretty sure I can solve that. 5x plus 18 plus 2 equals 30. That's going to be 20. I'm going to subtract it over and get 5x equals 10. So guess what? X equals 2. They got first 2 times. First, they got it 2 times. And everybody goes, yeah, you're right. How'd you know? And I said, I did the math. That's it. Stay happy, and I'll see you tomorrow.